Welcome back, Pre-Calc. Our objective today is going to be to write equations of parabolas. A lot of this will look familiar from Algebra 2, but there's some new stuff as well. I've got the checklist on the screen. Optional, but probably pretty beneficial for today, is also graphing paper. So our unit, chapter 8 from your book, is going to be on conic sections. And a conic section is the family of curves formed by the intersection of a double right cone and a plane. Okay, so basically what happens when you intersect that double right cone and a plane is you get four possibilities of shapes. You can have a circle, or an ellipse, a parabola, which is what we're going to be looking at today, and then if you just keep tilting that plane all the way kind of perpendicular to the ground, if you will, you get what's called a hyperbola. So we'll be studying these basically intersections this unit. All right, so I know you studied parabolas in Algebra 2, but I do want to revisit the formal definition of a parabola. So a parabola is a set of all points, x, y, in a plane that are equidistant from a fixed line, which is called the directrix, that's that red line on the screen, and a fixed point, which is called the focus, that's that green dot on the screen, and that focus is not on the line, okay? So once you find all the points that are equidistant from the focus and the directrix, you form a parabola. So for example, the vertex is definitely, hopefully according to this picture, equidistant from the focus and the directrix, right? Those should be the same length, same distance. Similarly, if I grab this point on the parabola, it should be the same distance from the focus as it is to the directrix, okay? If I grab this point, any point on the parabola, again, this distance should be the same as this distance, okay? So all points are equidistant from the focus as well as the directrix. And the focus is a point that sits inside the parabola, if you will, and the directrix is a line that sits outside. So before we dive into some examples here, I would like for you to just kind of look at these formulas as well as the graphs that are given, and I would like for you to go ahead and pause the screen and copy what we have, and then we'll kind of make sense of these equations, but I'm going to give you some time to pause here. Okay, hopefully you paused and we are back. So here's what I want you to notice. Well, first of all, let's take a look at the vertex. That didn't work. Your vertex is HK, okay, and notice that your H is always with your x variable and your k is always with your y, and you've got that negative inside parentheses as opposite, right? So vertex is hk. Now, when your x's are squared, you'll be opening up or down, just that is what you all looked at in Algebra 2, but when your y's are squared, now we're going to be opening left and right, so we're not looking at functions in terms of x anymore, okay? But parabolas can certainly still open left or right, and that just means that the y's are squared instead of the x's, okay? So now let's make sense of this 4p thing, okay? Because we've got that in both places, right? So can you pause the screen one more time and copy the purple parts, those two sentences? So go ahead, I'll give you some time to pause. Okay, hopefully you paused and we're back. So P is the translation from the vertex to the focus. Okay, so this is really important. What do I mean by translation? Well, I mean the movement from vertex here to here. And I'm saying translation instead of distance because P can be negative, okay? So if P is negative, then you're going to be moving down or to the left. Whereas if P is positive, that's when you'll get your parabola opening up or to the right, okay? And then the absolute value of 4p is your focal width. What do I mean by that? Well, that is this distance here. So it's the distance that's parallel, it should be parallel to the directrix, and crossing through your focus, okay? So that's what we call the focal width, and that basically makes how wide or skinny your parabola is. So we're not going to derive the equation quite yet, we'll do that in class, but let's go ahead and do some examples to make all these equations a bit more concrete. All right, I'm going to force a pause on your screen. Can you please copy what I have on the screen? Okay, we're back. So it says find an equation in standard form of the parabola with focus -5, 3 and vertex -5, 6. So I've got kind of graphing paper here, if you will. And let's go ahead and start by graphing to get a feel for, okay, where is this parabola opening? Which way? What does it kind of start to look like? So I'm going to go ahead and plot the vertex first at -5, 6. So my vertex should be there. And then my focus is at -5, 3. Okay, so what do you notice? What is the translation? Make sure I get that right there. What is the translation from vertex to focus? It is, wow, down 3, okay? So P is -3, this means I must be opening down, and so that tells me which general formula to use. So if it's opening down, would you say our x's are squared or our y's are squared? Our x's are squared. We have a vertical axis of symmetry. So I'm going to go grab that general formula. X minus h quantity squared equals 4p times y minus k. Okay, and I have hk, right? We have our vertex there, so I can fill that in. And I have my p-value already. And those are the 3 things we need to fill in our equation. So let's go ahead and do that. We've got x minus, now can grab, the x coordinate of your vertex, so minus a -5, so I'm going to have +5 here, squared equals 4p, well, p was -3, and 4 times -3 is -12, and then y minus your y value of the vertex, which is 6. All right. And that's our final answer, okay? We're going to be looking at graphing these a bit more, but again, just kind of a review of what this tells you. If you take the absolute value of that, that would be 12, right? This is called your focal width. So if I take 12 and divide by 2, I'd have 6. So I go 6 in each direction from the focus. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Again, that kind of gives me the width of my parabola. So this is kind of looking ahead, but that's what I would get if I were to graph this. All right, I'm going to force a pause on your screen. Go ahead and copy example 2 for me. So example 2 says, find an equation in standard form for the parabola with focus 2, -3, directrix 6, x equals 6, sorry. Okay, so again, let's start by just kind of plotting what we have so we can figure out which direction we're opening and that kind of thing, where our vertex is, etc. So my focus is at 2, -3. So my focus is right here, and my directrix is x equals 6. Okay, remember your directrix is a line and your focus is a point. Now, can you guess which way, can you see which way your parabola opens, up, down, left, or right? This is going to open left. And the reason for that is because remember that our focus has to sit inside our parabola, okay? So this also, let's go ahead and find the vertex here. I think that will help you see kind of where the parabola is going to go. So if I go right in between my focus and my directrix, but still with that same y value of -3, I would be right there, right? That's going to be my vertex, okay? So then it's going to open left. We just haven't found the focal width yet, okay? So that'll be my vertex. So if it opens left, should my x's be squared or my y's? My y's should be squared, right? So let's grab the general formula first. So y minus k quantity squared equals 4p times the quantity x minus h. All right, so we know the vertex, right? That's that purple dot labeled V. So we know HK. The only thing else we need is P, okay? And remember, P is the translation from vertex to focus. So I can see that it's going to take me 2 steps to go from vertex to focus. So do you want P equals +2 or -2? So P will be -2 in this case because you're opening to the left. In other words, you go left 2 to get from the purple dot to the red dot. Okay, so we have everything we need now. Let's fill it in. We've got y minus. Now grab the y coordinate of your vertex, and Notice that your vertex is the point 4, -3. So I have y minus -3, or y plus 3 quantity squared. And then 4 times p was -2, and then x minus h, and h is your x-coordinate of the vertex, and that was 4. All right, just cleaning this up a bit, we get quantity y plus 3 squared equals -8 y minus 4. And just seeing that p value is negative is a good indicator because we are opening to the left here. And again, just looking ahead a bit, our focal width would be the absolute value of that number, so it'd be 8. So I want this distance here to be 8, so going up 4 and down 4 from your focus. And again, that gives me the width of my parabola. Okay, I'm going to force a pause on your screen. Can you copy this and try it on your own? And when you're ready to see the answer, can you press continue, please? Okay, I have the answer on the screen. Go ahead and pause if you need to make any corrections, and then let's go ahead and try example 4, the last one together. All right, I'm going to force a pause on your screen. Can you please copy example 4, and then we'll do this one together. Okay, so example 4 says find an equation in standard form for the parabola with vertex 2, 3, so we know h and k, right? Opens to the right, so if it opens to the right, would you say that x's are squared or y's are squared? Y's will be squared, and we have a focal width of 5. Okay, so for this one, I think we have everything we need to go ahead and write our equation. So we know that since this opens to the right, that y's will be squared. All right, so let's start with that. Y minus k quantity squared equals x minus h. Sorry. Drop my 4p. 4p x minus h, okay? And we've got our vertex 2, 3, so that's our hk respectively, right? So the only other thing we need is p, but remember that for p, that your focal width is the absolute value of 4p, okay? So I can take that 5 and basically replace it with that 4p. The only question is, do we want p to be positive or negative? So do I want to use positive 5 or negative 5? What do you think? We're going to use positive because we're opening to the right, okay? So my focal width is 5, so I can replace that entire 4p, not just the p, the whole thing. Remember, the absolute value of 4p gives you your focal width, so I can replace the whole thing with positive 5, okay? All right, so we've got y minus 3 quantity squared equals 5 times x minus 2. And that is our final answer. All right, please go ahead and write a summary or a question in your notes, and I will see you all next time.